Oh, don't do that to me. Wait for it. Wait for it. Focusing. All right, cool. So here we are. Problem 7.51, part 2 of this third session of week 10. All right. So the fluid dynamic characteristics of an airplane flying 240 miles per hour at 10,000 feet are to be investigated with the aid of a 1/20th scale model, or 1 to 20 scale model. If the model tests are to be performed in a wind tunnel using standard air, what is the required air velocity in the wind tunnel? Is this a realistic velocity? All right, so we have a big plane that we're testing on a smaller scale in a wind tunnel that we have, but we want to make sure that the wind tunnel test is going to be a viable test here. Usually, if you have fluids moving, the Reynolds number is going to be a good way to test that, right? So we're going to look again at Reynolds number similarity here. Except this time we're going to use the relationship using density instead of the when using kinematic viscosity. So on my left-hand side, I'm using the model, and on the right-hand side, we have our prototype. And I know that, again, our model length is 1 to 20, our prototype. And the other thing that we're given is that it's flying at 240 miles per hour in the prototype, so VP is 240. So we have everything that we need, and what we're looking for is the required air velocity in the wind tunnel. So that is our VM. So solving this relationship up here into terms of VM, we have that, then rho over rho m, L over Lm, multiplied by our velocity. Well, I'll say velocity p. All right. And then we need values for each of these. This is going to be unknown. This is a relationship that we're given, but then we're looking at these two. So if you look at a table at 10,000 feet, this is your viscosity of air at standard air, which is what our wind tunnel will be, or our model, 3.74 times 10 to the negative 7th. Density of air at 10,000 feet. Density of our model at what is probably going to be just sea level. And then we know that, so we recognize that the density up here of our prototype is a lot less than the density of our of our model, which makes sense, right? So plugging in the numbers that we know and the relationships that we have, 3.774 times 10 to the negative 7th, multiplied by 1.756 times 10 to the negative 3rd, 3.534 times 10 to the negative 7th, 2.38 times 10 to the negative 3rd. And then our relationship between these two is 20, and then VP is 240. We get our VM is 3,750 miles per hour. And this is not realistic. Right? What wind tunnel is going to be able to generate that? And then, I don't know, it just doesn't make a lot of sense. So we're going to say this is not realistic. But what could we do instead? So thinking about something that we could do to kind of fix this problem for us. What if we tried a different substance instead of a wind tunnel? Right? Because that would change our viscosity, and that would also change our density. So one thing that I tried was put it in water. Maybe. Just to see if, like, if we had like a water tunnel, I guess you could say, if that would be a reasonable way to test this system. And we get a couple new values. I'll go ahead and just write those out, and if you want to look them up yourself, you can do that, or just backtrack to see what is what. I'll leave that up to you. But I'll just get the values here. So our relationship is still the same. Our velocity is still the same. Same viscosity there, same density here. Just a different viscosity and density in our model. We'll get 287.7 miles per hour, which I said was still pretty fast. Maybe more feasible, though. Kind of depends. So what you see is you can see in this relationship that we have, as our viscosity and our density change, so is the velocity of our model going to change. And so maybe if we put this in something like molasses and tried to move it in molasses, then that would change things. But the moral of the story here is that you're going to probably need a different model in this problem. But we're not asked about what the model size should be. We're just asked whether or not it's realistic, and it's not. That's what I got for today as far as problems go. Hope you were able to also check in on the last one. Oh, come on. Wait for this to focus. So again, if helpful, let me know, right? That way I can know what works, know what doesn't work, and then make this as good for you guys as possible. And also WebEx. I've already seen some people in the WebEx meeting, which has been a good time. Glad that I could see people there. But just making sure that I see you guys there, because that'd be helpful for a little bit of back and forth, question, answer. Right now, the content isn't too crazy, but it's going to pick up here the next couple weeks. So again, this is available Monday, Tuesday, Thursday. Monday at 6, Tuesday at 6, and then Thursday at 5 Iowa time. Don't worry about that. Anyway, so again, give me feedback, like, subscribe, hit the notification bell, whatever works for you, and then see you all on WebEx. Have a good day, everybody.